Hello, in this video I'm going to solve the following problem for you. This is a problem on the topic of quadratic equations, existence of roots. Consider the following quadratic equation: 1 plus m squared times x squared minus 2 times 1 plus 3m times x plus 1 plus 8m equals 0. For which value or values of m does this equation have no real roots? That would be a good idea if you pause the video at this point and try to solve the problem yourself first. If you do your calculations correctly, the answer that you would get is as follows. M should be positive, but not equal to 1/2. Okay, now let us solve this problem. So we want to fine-tune this parameter m in this quadratic equation for which, so that this equation does not have any real roots. So you know that a quadratic equation has three possibilities. Either it has no roots, or it has one single root, which we call the double root, or it has two roots. Okay, and what decides about this? What is called the discriminant, yes? So if I take this to be a, if I take this coefficient to be b, and this coefficient to be c, then you know that the discriminant of this quadratic equation is given by this formula, b squared minus 4ac. In order for a quadratic equation not having any roots, this should be negative. Yes, because you know that if you solve, for example, using ABC formula, you will have minus b. The roots are plus and minus a square root of d divided by 2a. D is this discriminant. And of course, if this is negative, then a square root of a negative number does not make sense in the set of real numbers, and we do not have any roots for our quadratic equation. So in order to force this quadratic equation not to have any roots, I have to force the discriminant to be negative. And what I have in my hand is controlling over the parameter m. So by fine-tuning the value of the parameter m, I can force the discriminant of this equation to be negative. Okay, so I plug these values, these expressions for b squared minus 4ac. So b squared is this expression squared minus 4 times a, which is 1 plus m squared, times c, which is 1 plus 8m. This should be negative. And then I do a little bit of algebra and try to solve this inequality. Okay? So when I raise it to power 2, minus 2 to power 2 becomes 4. And then this becomes 1 plus 3m squared. And then I have minus 4. Here I multiply this by that. So 1 times 1 plus 1 times 8m plus m squared times 1 plus m squared times 8m, 8m cubed. This is supposed to be negative. I see that I have a 4 here, a 4 there. I simplify both sides of this inequality by 4, so I divide everything by 4. So this 4 is gone. Then I square this using the squaring rule. So I expand that. It becomes the first one squared, 2 times the first one times the second one, and the second one squared. Okay, when I divide it by 4, this 4 is gone, but minus sign is there. So minus sign goes for all the terms within the pair of brackets. So it becomes minus 1 minus 8m minus m squared minus 8m cubed. This is supposed to be less than 0. Can I simplify things? Yes. So this 1 and that minus 1 are gone. So I would write minus 8m cubed first. Yes. And then I have 9m squared minus m squared. It becomes positive 8m squared. And then I have minus 8m plus 6m is minus 2m. This is supposed to be less than 0. Okay, so you see between these three terms, I can factor minus 2m out. From here, positive 4m squared is left. From here, minus 4m is left. And from here, positive 1 is left. It is supposed to be negative. Okay, Okay, we can double check. Multiply this back in. You will see that this multiplied here gives me this term. That's correct. Multiplying this by that, it becomes positive 8m squared. That's correct. And multiplying this here, it will give me this. So my factorization is completely correct. But hopefully you realize this pattern. So I can factorize this term more using the squaring rule. So I just write minus 2m, and this becomes 2m minus 1 squared. It is supposed to be negative. Double check again, the first one squared, 2 times the first one times the second one, and the second one squared. So that's correct. To simplify things a little bit, let me divide everything by minus 2. If I divide this by minus 2, the left side becomes this. But because I am dividing both sides of inequality by a negative number, I have to flip the sign. Then 0 divided by minus 2 is still 0. So this is what we get. So let us review. I want to force this equation not to have any roots. So it means that I have fine-tuned the parameter m so that the discriminant becomes negative. I wrote the discriminant, and this is just simplification of the discriminant. So this equation has no roots if and only if this happens. Okay, but that is not hard. You see, this part, this is the product of two numbers, is supposed to be positive. Okay, this number is already non-negative. Why? Because this is even power. No matter what 2m minus 1 is, if I square it, it becomes a non-negative number. Okay, but of course, sometimes it becomes 0. If I choose m to be 1/2, then this number becomes 0. The left side becomes 0. Greater than 0 is not correct. So I am not allowed to choose m equals to 1/2. So this is why m shouldn't be 1/2. Because if m is 1/2, the left-hand side becomes 0. 0 greater than 0 is not true. Okay, so m should not be 1/2. But if m is not 1/2, then definitely this is positive because of this even power. So the multiplication of m by a positive number is supposed to be positive. This can happen if and only if m itself is positive. Because if m is 0, the left-hand side becomes 0. 0 greater than 0 does not work. If m is negative, negative times positive becomes negative. A negative number cannot be greater than 0. That cannot work. So the only possibility for this combination to be positive is that m should also be positive. So if m is positive and not equal to 1/2, it is guaranteed that this expression is positive. This expression positive means this expression negative, and if you go back, it means that the discriminant is negative, and it means that the equation does not have any roots at all. Okay, that is why the answer to this problem is this. Okay, I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.